In this chapter, we are going to be focusing on a specific type of functions, linear functions. Now, the most basic definition of a linear function is that the graph of a linear function is a straight line. It can be an increasing line, like this one, increasing. It can be decreasing, or it can be a horizontal line, also called a constant function because the output remains constant all the way across the line. Now, also in this chapter, we will be studying vertical lines. Now, a vertical line is technically not a linear function. It is not really a function at all. It fails the vertical line test. So this vertical line, I'm going to draw a little X through it. It's not a linear function. It's not even a function. So everything that we learn in this chapter, the vertical line is going to be the exception to every rule that we learn. So talking about linear functions, when you talk about a linear function, you need to have some way of quantifying the steepness of the line, some way of distinguishing between a line that increases like this and a line that increases like that. And we do this by means of what is called the slope. Now the slope is a ratio of the change in the output variable to the change in the input variable. So if you take any 2 points on a line, let's just take a point here and a point here. I'm going to call this point x1, y1, this point x2, y2. The slope is the change in the output values. The output values are y1 and y2. So the change in the output would be y2 minus y1, the difference in the output values. Same idea with the input. The change in the input would be the difference in the input values. The input values are x1 and x2. So we would write x2 minus x1. So the slope has the formula y2 minus y1 over x2 minus x1. This is a formula that you will need to remember. Now, given any 2 points, you can draw a straight line connected them. That is enough to draw the graph of a linear function. It is also enough to find the slope. So we have some examples here, starting with part A, -2, 3, and 4, -1. I'm going to start by just plotting these points. Here is -2, 3. Here is 1, 2, 3, 4, -1. There's 4, -1. Draw a line connecting them. And you can see this line is decreasing. All right, we can also determine the slope of this line given these 2 points. Slope is defined as y2 minus y1 divided by x2 minus x1. As you go through these, it really does help to copy down that formula each and every time. It also helps to label your points. So I'm just going to start with this first one here. This first one, I'm going to call this x1, y1. The second one, x2, y2. Now I'm just going to plug these values into my formula. y2 is -1. So I'm going to plug in -1. Here's my minus sign. The minus sign stays there. Plug in y1. y1 is 3. Divided by, plug in your x values. x2 is 4. Minus, be sure to keep that minus sign in there. x1 is -2. All right, now notice I'm using parentheses around each of these values. That really helps to keep the signs in order. So always just be in the habit of putting these in parentheses. Now that we have everything plugged in, we can go ahead and work it out. -1 minus 3 gives you -4 divided by 4 minus a negative 2 is a positive 6. At the end of this, we're always going to have a fraction, so you always want to see if you can reduce it. Negative 4/6 can be reduced to negative 2/3. So the slope of this line is negative 2/3. Moving on to part B, we have another pair of points. We have negative 3, negative 1, and 4, 2. So I'm just going to go ahead and plot those as well. Negative 3, negative 1 would be about right there. And 4, 2, 1, 2, 3, 4, up 2 would be about right there. Connect the dots. And you can see we have, this time, an increasing linear function. All right, and we can determine the slope. The slope is y2 minus y1 divided by x2 minus x1. So labeling the points, this is going to be x1, y1. This is x2, y2. Plugging everything in, y2 is 2 minus y1 is negative 1 divided by x2 is 4 minus x1 is negative 3. All right, now I want to pause here and just point out the importance of keeping the values in the right place. First of all, the output always goes on top. The input values always go on the bottom. But notice how they line up vertically. All right, x2, y2, those values have to be right above each other. And the same with x1, y1. They need to line up vertically. That will make a big difference in the sign of your end result. So just be real careful when you plug those values in. All right, working this out, we have 2 minus a negative 1, that's a positive 3, divided by 4 minus a negative 3, that is a positive 7. Looking at this fraction, 3/7 can't be reduced, so we're just going to box it up. That is our slope. Example C, we have the point 3, 2, so 1, 2, 3, up 2, right about there, and negative 1, 2, there's negative 1, up 2, connecting the dots, and you can see here we have a constant function or a horizontal line. And let's see what happens with the slope here. Slope, again, copying down the formula, y2 minus y1 divided by x2 minus x1. Labeling the points, there's x1, y1, there's x2, y2. Plugging in the values, y2 is 2 minus, y1 is 2 divided by, x2 is negative 1 minus, x1 is 3. Working it out, 2 minus 2 is 0 divided by, negative 1 minus 3 is negative 4. So we have 0 over negative 4. Now whenever you have 0 divided by any number, the result is just 0. So the slope of this line is just 0. All right, moving on to example D, or part D. Here we have the point 2, negative 3. So there's 2, negative 3 is about there. And 2, 1, right about there. Connecting the dots as neatly as possible. All right, you can see that here we have a vertical line. All right, vertical line, not a function, so we kind of expect something strange to happen when we compute the slope, but let's go ahead and try it. Slope is equal to y2 minus y1 divided by x2 minus x1, Plug in the values. This is x1, y1. This is x2, y2. So y2 is 1 minus y1 is negative 3 divided by x2 is 2 minus x1 is 2. Working out the top, we have 1 minus a negative 3 is 4, divided by 2 minus 2 is 0. Now, here you have 4 divided by 0. Now, in mathematics, you can never, ever divide by 0. That just cannot be done. So here, the slope is undefined. It does not exist. A vertical line has no slope. All right, so generalizing what it is that we've done here, whenever we have a line that is increasing, that means that as the input increases, so does the output. When you compute the slope, you will always either have a positive number divided by a positive number, or a negative number divided by a negative number. In either case, the slope will always, always, always be positive. If you have an increasing line, the slope is going to be positive. Now, by a similar logic, if the line is decreasing, the signs will be the opposite. As the input increases, the output decreases. So when you compute the slope, you will either have a negative value over a positive, or a positive divided by a negative. In either case, when you reduce, the end result is going to be negative. So the slope of a decreasing linear function is always, always going to be negative. For a horizontal line, the outputs never change. It's a constant function. So it's always going to be 0 divided by some number. 0 divided by any number is always going to be 0. So the slope of a horizontal line or a constant function is always going to be 0. Similarly, with a vertical line, you're always going to be dividing by 0. The inputs never change. All the inputs on a vertical line are the same, so you're always going to have something divided by 0, which is undefined. All right.